Now introduction of acid and bases we will see first. The term acid and base becomes so common in routine and involve such a variety of substances that have been accepted as such without questions. Several definitions of acids and base have been proposed time to time. Going back to historical development of the subject, acids were earlier characterized by their SAR test. Okay, ability to dissolve substances in water and action on vegetable dyes, etc. Like that the definition, they used to define the acid in such a way. Okay, then we can say what is pH? pH, I have told you, the pH is actually a range from 0 to 14. Okay, and 7 is neutral. So before this part is for acid, okay, and this part is for base. So if we say the pH is 7, it means substance is neutral by nature. If we say pH is 4, means substance is acidic by nature. If we say substance is pH is 10, means substance is basic by nature. More the value of base, more is the basic nature. Less the value of acid, more is the acidic nature. Like that it is. Okay. So if we say the pH is 6.8, means weakly acidic substance. pH is 7.8, it means weakly basic substance, like that. Okay. So further salts are produced by neutralization reaction between acid and base. For example, we have HCl, hydrochloric acid, which combines with sodium hydroxide, we get sodium chloride. The table salt which you eat every day is sodium chloride and water. Okay. So anytime when the salt and water, acid and base combines, you are getting salt and water. Okay. So depends now what kind of acid and what kind of base is combining, accordingly you are getting different type of salts. Like if the strong acid and weak base is there, the salt obtained is more of acidic character, so acidic salt. If strong base and weak acid is combining, you are getting basic salt, like that. If both are strong, both strong acid, strong base, or both are weak acid, weak base combining, you get always neutral salt, like that. So salts are also three types: acidic, basic, neutral. Like this we are saying strong acid, strong base, and weak acid, weak base, different categories. Now substances in SAR test regarded as acids, like for example lemon juice, vinegar, grapefruit juice and spoiled milk, all are testing SAR since they are acidic in nature. Okay, lemon juice will have citric acid present in it, then vinegar will have acetic acid present in it, grapefruit juice also has citric acid, similarly milk will have lactic acid. So there are different kind of acids present. Similarly substances with bitter taste, soapy touch are regarded as bases. Okay, so these are called bases. Like for example we say here only examples are there. Caustic soda is sodium hydroxide, caustic potash is potassium hydroxide. Okay, so these are slag lime, calcium oxide. These are the different kind of examples of bases. Now what are the acids? Acids are SAR in test. Now these are the daily life objects. You are using tomato, so which acid is present in tomato? Oxalic acid, H2C2O4 is the formula. Okay, you are using tamarind, there is a tartaric acid, that is C4H6O6. We are using vinegar in different kind of food items. Okay, like especially if you are eating any kind of noodles or any kind of Szechuan rice or that kind of recipes, or tomato ketchup, in that also preservative also vinegar will be used. Vinegar is acetic acid, CH3COOH. Lemon will have citric acid present. So these are daily life examples where the acids we are using it in a smaller quantity. These are very dilute kind of acids. This does not harm to the body. Always it gives, actually immunity power will increase by eating. It has a lot of enrich in vitamin C. So all SAR substances will enrich in vitamin C and they will be increasing your immunity, okay, towards the different kind of germ, insects and microorganism attacks. Then the term acid is derived from the Latin word acidus, okay, meaning SAR to test. What is the meaning of this SAR2 test? The word acid was applied to substance with SAR test. Many substances can be identified as acids based on their taste, but this cannot be sole criteria for acidic character. Okay, like we cannot say ki substance is only SAR to test, so it is acid. If it is not SAR to test, it is not acid. It's not like that. So this cannot be a sole criteria. There are different criterias. Now see there, we say an acid may be defined as substance which releases one or more H plus ions in solution. Okay, one or more H plus ions in solution. Like for example, sulfuric acid H2SO4 will give 2 H plus ion. H2 is there plus SO4 minus. If we SO4 2 minus. If we say HCl, 1 H plus ion. H plus into plus Cl minus. How it will break? It will give H plus plus Cl minus. Okay. Then acids are mostly obtained from natural sources. Those obtained from rocks and minerals are called mineral acid, like hydrochloric acid, nitric acid comes under mineral acid. Then while the acids present in animals, so these are called mineral acids. Okay. What is the difference mineral acid and organic acid? There is how it is obtained. If it is obtained from rocks, it is called mineral acid. If it is obtained from plant or animals, that is called organic acids. Like for example, citric acid from oranges, tartaric acid from tamarind, like this. Okay. Bases can be identified as a bitter test and soapy touch. However, this cannot be a sole criteria again to identify a base, same way like acid, since many of them like sodium hydroxide and potassium hydroxide has corrosive action on the skin and even they harm the body. So we should never touch by hand. We should wear gloves, or we should use a spatula or spoon or scooping. Then only we should use. We should not directly touch this kind of substances. They are highly corrosive. Corrosive means it can give blisters to your skin. It may directly immediately reacts to your skin. Okay. So NaOH, KOH or the strong bases, they are very corrosive in nature. Corrosive means they will harm the skin. A base may be defined as substance capable of releasing one or more OH minus ions, okay, in aqueous solution, like sodium hydroxide, potassium hydroxide in water soluble. Like for example, NaOH will give how many OH ions? 1 OH ion, Na plus and OH minus. If we talk about any other like calcium hydroxide, so on dissociation it will give Ca2 plus and 2 OH minus ions, like this. Okay. So how many OH ions are given, that will decide the basic character of that substance base. Okay. Then we are saying strength of an acid does not depend on the concentration of an acid. It depends on the concentration of hydronium ion which is obtained on dissociation. Bases which completely dissolves in water are called alkalis. Examples NaOH, KOH are the bases. So all alkalis are bases, but all bases are not alkalis. Why this statement we are using? Because the bases which are water soluble are called alkalis. Which are not soluble in water, they are not called alkalis. So that's what all alkalis are bases, water soluble, but all bases are not alkalis. Okay. Acidity is determined by number of OH minus ions produced by per molecule of a base, and all alkali, like see, this is called acidity. So NaOH will break into Na plus and OH minus. So how many OH minus ions we got it? We have got it here OH minus ion only 1. So what is the acidity? Acidity is 1. Okay. Acidity of this base is 1. That is called monoacidic base. Okay. Now if we say this another substance, okay, calcium hydroxide, it will break as Ca2 plus and 2 OH minus. So how many we are getting, how many OH minus ions here? That is only deciding the acidity. So acidity here is 2. Okay. So this is called monoacidic, this is called diacidic, like this. Okay. Next we are seeing here mineral acids, generally obtained from minerals or rocks. Okay, so hydrochloric acid, then sulfuric acid, nitric acid, carbonic acid, phosphoric acid. Now if we see same time the substance which has number of replaceable hydrogen atom, that is called basicity. What is basicity? We will study simultaneously. We will choose another color for this so you can easily see what basicity. Basicity will be number of replaceable hydrogen atoms. Okay, so here how many hydrogen atoms? H plus. So basicity will be 1. Okay, so how much is the basicity? We will write there that side basicity so you can understand it properly. We will write here basicity. Okay, so here it will be 1. Now in this case how many? 2H plus. So basicity will be 2. Monobasic, dibasic, here again 1H plus, so it is 1. Here again 2H plus, so here again 2. Here 3H plus, so the basicity will be 3. So what name we can give? We can say this is monobasic, this is dibasic, and this is tribasic. Okay, what is basicity? Number of replaceable hydrogen atoms present. Okay, on dissociation we are seeing, if it dissociates, how it dissociates? H plus and Cl minus, like this we can write, or we can write SO4 2 minus, here NO3 minus, here plus CO3 2 minus, okay, plus PO4 3 minus. Okay, like this. So next we are talking organic acids, generally obtained from plants and animals, that is acetic acid, formic acid, benzoic acid, citric acid, all are the examples. Okay, then you can see here the acid prepared from minerals are called mineral acids. Mineral acid, this kind of sign will be there on the bottle. What is this sign? The acid is very corrosive. It will harm the skin. It will injure the skin. You would have heard about acid attack. Acid attack is generally done by sulfuric acid. The concentrated sulfuric acid is the most dangerous acid. Okay, and it will directly burn the skin till the bones also. Okay, and it is very disastrous if it happens with someone, which should never happen with anyone, but always a person. In the lab also, if you are using this acid, you have to be very careful. Okay, because this acid laboratory it will be used in little diluted form, but still it will burn the skin if it is falling on skin. It will burn the cloth also if it is falling on cloth. So we have to be very careful while doing the experiment. So H2SO4 is sulfuric acid, HCl is hydrochloric acid, HNO3 is nitric acid. Concentrated acids are dangerous in lab, generally mixed with water to dilute them. Such acids are called dilute acids. Always add acid into water to avoid any accident. Why? Because if you add water into acid, then the acid will spurt out and it will cause accident. It will spurt out, it will fall on your skin, your clothes, it may cause accident. That is why always add acid into water, so it will not spurt out. Next we are seeing here, there are different kind of examples are given here. So acids are classified: organic acids, mineral acid, organic acid which is obtained from rocks and minerals, mineral acid which is obtained from plants and animals. Okay, it is reverse: mineral acids which is obtained from rocks and ores, organic acid which is obtained from plants and animals. Okay, now let's see here mango, which kind of acid is present in this? Citric acid or malic acid, tamarind, tartric acid, then oranges, citric acid again or malic acid, grapes, tartric acid, lemon, again citric acid. So citric and tartric acid is majorly we are eating at home, I think, in food items every day. Okay, now we see based on number of hydrogen ion or hydronium ion produced, acidity or basicity of a substance. Now monobasic acid. when on one molecule it gives on hydronium ion on dissociation, 1 H plus ions are obtained. So these are called monobasic acid. When on dissociation it gives 2 hydronium ion are called dibasic acid, sulfuric acid. On dissociation it gives 3 hydronium ion, they are called tribasic acids like phosphoric acid or citric acid also. Then let's see the next one, basicity. There was, based on their strength, they can be also 2 types, strong acids which dissociates completely, so HCl breaks to H plus and Cl minus in aqueous medium, sulfuric acid, hydrochloric acid, all. Weak acids, they undergo complete ionization in incomplete ionization in aqueous solution. That is why we are showing reversible arrow here. Reaction doesn't complete. In reaction there are ions as well as undissociated molecule is also present. So acetic acid, ammonium hydroxide, these are the weak acid, weak bases are present. So this is weak acid, acetic acid, formic acid is also weak acid. Okay. Then we have concentrated acid. The acid, they contain less amount of water and more amount of acid. Dilute acid, they contain large volume of water and less amount of acid. Okay, lots of water we are adding and we are making it diluted. Okay, now we can see bases, bitter to taste, like fenugreek is very bitter to taste, bitter gourd is very bitter to taste. Okay, so these are the substances which has basic substances present. So on the basis of number of hydroxyl ion it gives, we can divide it into monoacidic, diacidic and triacidic, like that. So if we say, see here, monoacidic means how many hydroxyl ions it is giving, Na plus plus OH minus, so 1 OH minus. So this is called monoacidic. Okay, one example we will take here, from here, like for example MgOH2, magnesium hydroxide, when it breaks you are getting Mg2 plus plus 2 OH minus. So how many OH minus ions are giving? 2. So the acidity will be diacidic. Okay, if we say FeOH thrice, FeOH thrice will be giving Fe 3 plus plus OH 3 OH minus. So how many OH minus? 3. So it is called triacidic ions. Okay, so depends on how many, the basic character will be decided on how many OH minus ions are dissociated. Okay, so strong bases will undergo complete ionization, weak bases will undergo partial ionization. Again, the strong bases reaction we are writing with the single headed arrow, means that indicates the reaction has completed in right hand direction only, that is called forward direction, and ions are completely obtained. Okay, reaction completed. But for weak bases what will happen? For example, if we talk calcium hydroxide, so we are writing reversible arrow. Arrow is in both the direction because the dissociation has not completed. Dissociation is not completed means the part of ions are obtained and parts of undissociated molecule is also present in the solution. That is why reversible arrow is present. Okay, both the stages are there. Reaction goes in forward direction as well as backward direction. Concentrated bases, they contain less water. When we add more water it will be called dilute solution. Less water. Dilute acids or dilute bases, they contain excess of water. Lot of water is added, you are making a dilute solution. Now what do you mean by indicators? Indicators means when reaction completes. Suppose you have two colorless solutions, you are mixing it to them. Now we are saying when acid and base are mixed we are getting salt and water. But when acid and base are mixed and when the salt is obtained or not, how to identify? Because the obtained salt solution is also colorless. So to identify the reaction is completed, we have something called indicator which will show the color change. When the reaction completes, the color change will happen. And as the color changes, you can identify the reaction is completed. Like you would have seen when you drive a vehicle, you are very young to drive maybe, but you would have seen on the road when the vehicle is there, if you have to go right hand direction, Olden times that indicator concept was not there. People used to show hand action. Now also hand action is also there, as well as there is a because AC vehicles are there, so the vehicles windows will be closed, and that is why there are indicators. So indicators are specific colored lights, correct? So the indicator is flickering on right hand side means person wants to take a right turn. Indicator flickering on left hand side means indicates person wants to take left turn. So without talking, without showing any hand action, you can communicate with the person who is coming behind you or from opposite side which direction you wanted to go. So that is called you are indicating it. Okay, so that is only here also same way. To indicate the reaction is completed or not, the color change will obtain. As the color changes, you are observing it as indicator. Okay, so here we can say we have a litmus paper. We have red color litmus paper and blue color litmus paper. Whenever we have, see now this red color litmus, red litmus remains red in blue changes to red. What happens when red litmus turns to blue? Blue is for basic. It means substance is basic in nature. Red litmus is turning red. It means substance is still acidic. So red litmus will not change color if it is dipped in acid. But blue litmus, if it is touched with the acid, it will turn red. It means the substance is acidic in nature. Now we can see here blue litmus, when we dipped it in a basic solution, it will be blue color. It will not change the color. But if we dip red litmus in basic solution, it will change blue color, means it is a base. Okay, so like that, red to blue and blue to red will indicate the substance is acidic or basic by change of color in litmus paper. Now acids are sour in taste and change the color of the blue litmus to red, whereas base are bitter and changes the color of the red litmus to blue. Litmus is a natural indicator. Turmeric is another such kind of indicator. Okay. Now you would have seen the turmeric. Whenever any kind of soap is touching to the turmeric stain, if any turmeric stain are there in your cloth, you at home you do the experiment, you try to rub the soap bar on that turmeric, you will see it will turn red color. So that is indicating whenever it comes in a contact with basic substance, it will turn that color. Okay, so how the litmus is obtained? It obtains from lichens. These are lichens. Lichens are it is a purple color dye which is extracted from lichens. A plant belong to the division Thallophyta and is commonly used as an indicator. When the litmus is neither acidic nor basic, the color is purple. Okay. Now we can see here, this is purple cabbage, example is given. So natural indicators can also be prepared from, there are many other natural material like red cabbage, leaves are there, turmeric, colored petals of some flowers, some as hydrangea, petunia and geranium, which indicates the presence of acid or base in a solution. They are called acid base indicators, sometimes simply indicators. So in acid and basic medium they give different color change, so they are identified as that kind of indicators. Okay, so these are natural indicators we are talking first: petunia, turmeric, geranium, beetroot and red cabbage extract. Okay, let's see what are the natural this is the natural we can say indicator, red cabbage extract. They will make an extract and they will try to test it, how it is acting as a universal indicator, means it is called universal indicator. Why? Because in acidic medium it will give acidic color, in basic medium it will give a different color, so we can identify substances acidic to basic. In pH strip also substances will show. See now, this is from strong acidic to neutral to strong basic, like this. It is a pH change. Okay, so strong acidic 1 2 3 4 5 6, up to this is strong acidic, then 7 is neutral, 8 to 14 is again basic. You can see the color change from purple to blue, then another blue, further blue, and then it is turning yellow. So the very strong basic, different color will show. So here you can see the red cabbage extracts remain red in acidic solution and turns blue to green in basic solution. Okay, like that we can see the different kind of flowers, like hydrangea flowers we can see, usually blue in acidic medium and turn pink in the presence of base. We can see here the blue and pink color also because of the particular kind of acidic or basic substances present in the air with that also. Or if we sprinkle some kind of acid or basic substance, we can see the color change also on that.